This is another example involving energy transfers and work done. We can therefore also use the work-energy principle to solve it. As usual, we need to read the question, visualize the situation, perhaps draw a diagram, label the initial and final situations, and so on. So I'll give you time to do that. Stop the video and do that. Okay, so the situation looks something like this. Initially, the skier has 0 velocity. He skis down the slope 2,000 meters, that's 2 kilometers, as said in the question. We have to convert it to SI units. He ends up with a final velocity of 10 meters per second, so he has some kinetic energy. He has lost gravitational potential energy, and so in this case we have gravitational potential energy involved, we have kinetic energy involved, but we also have work done by the friction force. Now the friction force opposes his motion, so will obviously act in that direction. It is known as 20 newtons, and it is acting for the whole of the 2,000 meters that he's sliding on the snow. So let's apply the work energy principle. We need to, as usual, set a 0 for the gravitational potential energy, and that is usually done at the final position, or the lowest position, in this case here. So the H will be 0 here. So initially, he's got a total mechanical energy, which is found by the sum of his kinetic energies, a half mv squared, plus gravitational potential energy, mg, times h, or the change in height. In this case, the kinetic energy initially is 0 because he's at rest. It says the skier skis down from rest. So he just has gravitational potential energy. The mass of the skier is, of course, 100 kilograms, multiplied by g, which we approximate as 10, multiplied by the change in height, which we don't know, but we do know that it's an unknown h. So we have h in this case here. And so that gives us the gravitational potential energy. We now have to add to that the work done. And so the work done is actually equal to the force times the distance it was acting for. The force, of course, in this case is 20 newtons, multiplied by a distance that it was acting for of 2,000 meters. And all that equals the total mechanical energy finally in its final situation. And of course, that is also the sum of the kinetic energies plus the gravitational potential energies. The kinetic energy is found by a half times the mass of the skier, which is 100 kilograms, times the speed squared, and we know the speed in this case, so that is 10 squared. So all that gives us the kinetic energy, and we add to that the gravitational potential, which, because of the height being 0, gravitational potential is 0. So if we do the mathematics, the only unknown in this equation is, of course, h. And so we will come up with h equals something which is measured in meters. As usual, I'll leave the mathematics to you.